that we are going to cover in the next 5 days, including an exam prep in the day number 5, is the Microsoft Cybersecurity Architect, the SC-100. This course was the last one added to the Microsoft official security certification path, and is representing, well, maybe you already know that there is multiple levels on the certification, starting with a fundamentals, for example. Then there is multiple other courses and certifications in the associate level. It's another level above the fundamentals. And they are in the security path is this identity and access administrator, security operations analyst, information protection administrator, the security engineer, the Azure security engineer, the AZ-500. And this is the expert level, the cybersecurity architect. It was added like the last 3 to 4 months ago. And because of that also, there is not official lab exercises released yet for this course. Instead, there is a couple of case studies that you are going to work with during every of the modules that this course includes. Okay, so let me start with an introduction about myself. My name is Eduardo Lopez, my batch of the MCT, the Microsoft Certified Trainer. About this course information, the Microsoft Security Architect is a role that has subject matter expertise in designing and evolving the cybersecurity strategy to protect an organization's mission and business processes across all aspects of the enterprise architecture. And the cybersecurity architect will design a zero trust strategy and the architecture. We are going to define little by little during the modules all these concepts, including security strategies for data, applications, access management, identity, and infrastructure also. And the cybersecurity architect will also evaluate the GRC, or governance, risk, and compliance, technical strategies, and security operations strategies also. The learner should have the following prerequisites. This is usual in this type of courses, that is including a multi-level from fundamentals, associate, and expert, that the levels that are on the top are assuming that you already have the knowledge from the previous one. So it is recommended and it's ideal that you already took some sessions like this, but into the previous associate level, for example, like the security operations analyst, the SC-200, the SC-300, identity and access administrator, AZ-500, and some of them, because this course is not going to focus on covering all those conceptual things and topics that the previous sessions cover. In some cases, it is. We are going to see it again, but the focus for this training is more into the architecture and design, following best practices and security, not more like a technical part. So we are not going to learn how to create virtual networks and how to interconnect that. There is other courses for that. But we're going to see that there is reference architectures to follow best practices on networking, compute storage, identity and access management, and so on. So learners should have the following prerequisite knowledge for this course: knowledge about identity and access, platform protection, security operations, securing data and securing applications, experience with hybrid and cloud implementations also. And this course will help the learners to prepare for the Microsoft Cybersecurity Architect exam, or the SC-100. As part of the team also, we have a moderator. Armin is taking all of your questions into the Q&A session, so please feel free to ask your questions at any time. How this session will run: we have 2 hours from the beginning of the session for these presentations, demonstrations, and so on. Then we will have, after those 2 hours, a 30-minute break. And after that 30-minute break, we're connecting to a lab and Q&A session, that in this particular case, because there is no lab, there will be a Q&A session, because, well, we are limited on time. We only have 2 hours for presentation. And usually there, on a single day, on a regular training, we will have from 6 to 7 hours of content, basically. So because of that, you will have some homework from every day. So that means that on a regular day, for example, that we should cover a couple of modules per day. I will partially cover those 2 modules per day, but you will have some topics that you will take as your homework and you need to study after we just finished with this session or during the Q&A session where you're starting and taking the case studies and so on. You can start asking all of your questions using the QA platform on it. We will be available for you to answer as much as possible to all of your questions during those final 2 hours and a half. So in total, we will have 5 hours of the session. Well, removing the 30 minutes of the break, 5 hours or 4 hours and 30 minutes on every day session for that. And every day with 2 hours, 30 minutes after that of break, and then 2 hours and a half for Q&A, or in the sessions that apply with lab and Q&A also. The course entire agenda is divided into 10 modules. So basically we have 5 days to cover, and well, actually there are 4 week content, and the final day is just for an exam prep that we have some knowledge questions or practice questions and so on, and some other content that we will present. But well, we have an average of 2 to 3 modules to cover per day, partially, and the other topics from those 2 or 3 modules you will take in as your homework. So the course agenda is for module number 1, we're going to start talking about conceptual thing about the zero trust, building an overall security strategy and architecture. Module 2, another conceptual thing for the same zero trust, design a security operations strategy. Module 3, design an identity security strategy. Module 4 for GRC, for governance, risk, and compliance, to evaluate a regulatory compliance strategy. And Module 5 for evaluate security posture and recommend technical strategies to manage risk. Module 6 for infrastructure security, understanding architecture best practices. Number 7, infrastructure security again, design and strategy for securing server and client endpoints. And Module 8, infrastructure security also, design a strategy for securing platform, infrastructure, and software as a services. Module 9 for designing data and application strategy, security requirements for apps or for applications. And Module 10, design data and application strategy, design strategy for securing data. If we would like to take a look at the weights that the exam will take as consideration when you are sitting for the exam is divided into 4 different study areas. The first one, design a zero trust strategy in architecture. If we would like to compare, the first study area is associated with the first 3 modules, module 1, 2, and 3 for zero trust. Design a zero trust strategy in architecture, the weight 30 to 35%. The amount of weight is associated with the expected number of questions that you will expect to see when you are taking the exam. From the 100%, 30 to 35% will come from this study area for the design a zero trust strategy, or from the first 3 modules. Next study area is the number 2, evaluate governance risk compliance, or GRC, technical strategy and security operations strategies. The weight is 20 to 25%. And if we wanted to see it in the number of modules, those modules are the module number 4 and 5, 2 modules for that. The study area number 3, design security for infrastructure. There is 3 modules, another 3 modules, module 6, 7, and 8. And there is another 20 to 25%. And finally, the study area number 4, design a strategy for data and applications. The last 2 modules, modules 9 and 10. The higher the percentage, the more questions we are likely to see in that area. Some other recommendations. During this cloud week, the live sessions will try to cover the full curriculum of tracks, including the ones guided by the instructor, and the other section that is like a self-paced that you are taking content as homework. The content from some time ago, especially this year or the last 6 months, Microsoft is now not distributing the digital courses using a different platform. and is now using Microsoft Learn. So if you would like to see this content also for checking in or using any kind of device, you just need an internet connection. You can go for Microsoft Learn, or you can go for aka.ms/learn, and you will search for the content, especially for this one. Or you can just open your preferred search engine like Bing, for example, and you can start typing in SC-100. And on your first results, you will find out the cybersecurity architect course from Microsoft Learn, and you will find out all of these modules there. So there is no codes that will be distributed or nothing that you need to redeem. You just need to look for that or going for Microsoft Learn URL, and you will find out the content there. If the course comes with the labs, well, when you're signing in to the platform to join the session, then you will find a section for the labs or for in the tab of resources. Most of the tracks, not this, will include some labs done during the sessions and a homework that you should complete on your own. Live sessions are recorded, but the recording will be available on demand the next 5 to 10 days after the cloud weeks conclude. So you will have access and you can just retake, let's say, or taking some of the content that you just lost on one of your days, for example. Okay, well, some information here. And well, if you're already certified, Microsoft also has been establishing some expiration for the certifications, especially because the cloud services like the Microsoft 365, Office 365, Microsoft Azure, and so on, and the new security ones, these type of platforms are being evolving really quick, or there's an evolution for that, like a new services, updates to existing services, and so on. So basically, most of the certifications has right now an expiration of a year, because every year there would be a big, sometimes a big percentage of changes from the last year, for example, of new improvements, new updates, new services, for example. So that's why there is a certification renewal process or program. All of the already certified uh, individuals in Microsoft, you will start receiving 3 months before your expiration emails with like a reminder that you have a soon to expire certification. And from that point, at the time that you just receive the first email, and other emails will be sent there eventually if you, for some reason, you didn't pay attention to the first one or you don't have the time yet. But the same information will be distributed by that email that will include links with the for taking an assessment. And that assessment, it is not like the full exam that you took originally for your certification with 45 to 50 or 50 something questions that you have like an hour and a half or 2 hours to take it into a testing center on a specific place if it is available, or into your home or office or something. And you're just taking an assessment online. That it is not the same process. It is going to be not taken by a proctor. You don't need a software installed into your computer or something like that. And you don't need to send proof of identification. You just need to authenticate basically with the MCP. And you can take the assessment that usually will be between 25 to 30 questions on. And if you don't score at least the 700 or 650 points or something, that will depend on every certification. There's no problem, because you can take that assessment multiple times when you just feel ready, but before the 3 months of expiration, you can take the assessment. And if you score the minimum score required, then you're just renew it for another year, basically. And the same process repeats again every year, or 3 months before the expiration. But if you didn't take, or you do not take that assessment when the 3 months expire, then your only way to recover the certification is for taking the official exam again. Okay, so be careful with that and try to leverage that certification renewal process, and don't let that your certifications expire. You can follow the URLs uh, that I'm presenting basically on. So with an aks.ms/cert dashboard, for example, or you can take a screenshot right now, or you can ask your question and we can paste it for you in the Q&A session. If you would like to just copy and paste it. Well, and also the links distributed for joining these sessions or the lab and Q&A were distributed by a calendar invites or using a different method. Check into that channel that you receive the URLs or the links for the sessions, and you will find out the one for the lab and Q&A. It is like a joining to another session, but after we finish with this one, basically with a separate URL. So we will join like to a new session, and then we have the 2 hours and a half within that. That will be a complete, let's say, an offline session where nobody's going to present unless that I consider that I need to present for answering to a question or something like that. But we are just basically interactive in real time with you, but through the Q&A tool, okay? So for your information, guys. Okay, so let's buckle up and let's start with the content because we are limited on time. So it's important for us to try to cover that part. Well, before starting with the presentation, then I would like you to show you the plan that I have for you today. And for day number 1, we have the lecture and the demo here with the 2 modules that we're going to cover today. In my case, the 2 modules that I will cover partially. The ones that I just color in yellow are lessons into module number 1. Module number 1 is to build an overall security strategy and architecture with the Zero Trust. And then these are going to be the lessons that I will present, basically. But these are not all of the lessons or topics for module number 1, because some of those topics or lessons from module 1 are designed as your homework for the day number 1, basically. So the lessons that you will take as your homework or that you can work with during the Q&A session, the 2 hours and a half, are going to be the translate security requirements into technical capabilities, design security for our resiliency strategy, and design a security strategy for hybrid and multi-tenant environments. And there's one exercise to build an overall security strategy and architecture. The yellow ones for module 1. Now, into my presentation also, I will switch eventually from module 1 to module 2. Design a security operations strategy on it. And the topics that I will cover is to understand security operations framework, processes, and procedures, design a logging and auditing security strategy, and develop security operations for hybrid and multi-cloud environments, while you are taking as your homework from module 2 a couple of lessons also, like designing a strategy for SIEM, for security information and event management, and security orchestration. Then the lesson for evaluate security workflows and review security strategies for incident management. Okay, so this is going to be the content for the day number 1. So, well, give me a second to start with presentation for the module number 1. And the module 1 name is Design a Zero Trust Strategy and the Architecture. And we're starting with this lesson, build an overall security strategy and architecture here. So what's the role of an architect in general? Usually, as a member of an organization, as a role of an architect, it is not to just performing like an operational role, to perform daily tasks to create or administering resources. Usually, an architect is involved into the process of designing something or create the foundations for something into migration process, adopting to the cloud, or digital adoption, basically, like the new tendencies on it. So it's going to participate and it's going to communicate with multiple stakeholders and members of the same organization to build, to design, and to maintain, for example, the security functions, especially as security architect of an organization and an IT environment. So can help the security architect to translate an organization's business and assurance goals into a security vision by providing the right documentation, diagrams to guide some technical security decisions on it. A Microsoft cybersecurity architect will have some expertise in designing the cybersecurity strategy to protect an organization mission, business processes across all the aspects of the enterprise architecture. And it will help to design the zero trust strategy and the architecture, including security strategies for data, for applications, access management, governance, risk and compliance, and infrastructure. So security operations strategies also, and it will continuously collaborate with the leaders and practitioners in the IT security, the privacy, and other roles within the same organization to plan and implement a cybersecurity strategy that will meet the business needs of an organization. That's about the role. Now, let's talk a little bit about the concept of the zero trust. Because, well, today, every organization will need a security that can adapt to the complexity of a modern environment. Modern environments usually will involve working on hybrid environments. And a hybrid environment means that organizations may already have some private cloud. That means that they own its own infrastructure already because they have been working for that way for many years. And it is the adoption of the cloud services. It is not just a matter of switching from one side to another or opting for one option or the other, but to work at the same time with your same private cloud infrastructure, plus you have the opportunity to also integrate the cloud services for different reasons. And it is convenient to operate into that model at least for these years or for a couple of years in the near future, for example. Some other organizations, like for example, like startups, where they don't have the capital expenditure already, or they don't want it to have its own private cloud, and they actually don't need it. They can just born, let's say, fully on cloud services. Or in some cases, organizations doesn't need to stick to one cloud service provider, but to work with the different ones at the same time. So working on hybrid, it's well, the organization needs to adapt to this way to work within this kind of model. And working with hybrid also, there's other tendencies like the bring your own device that enables users to use virtually any type of device or endpoint to access seamlessly to all of the services and applications that they need to virtually from any place and using any kind of device and using any type of operating system, for example. But these two concepts also, at the same time that adds value or convenience for the organizations, also represents or could represent a big exposure to different attacks or vulnerabilities on it. Because if we don't take care about the type, if we are trying to accept that any person using any kind of device to authenticate, sign in, and consume services or data, then if we don't have the proper protection for those endpoints, then we can introduce a lot of issues or problems or security risk that we don't want to. So we need to also have the foundations to make that everything to work and to have protection at any place. And this is how the zero trust concept is starting to make any sense. And why is that? Well, because zero trust teaches us to never trust, but to always verify. Because in the past, for example, if we would like to go back and move on or checking in, how was the model working into a private cloud infrastructure? where there is a physical space like an office or like a corporate building or something like that. When usually into that physical place, there were a physical network and there were like a domain infrastructure, for example, with devices and with Windows Server and with Windows devices and operating systems, where everything that was inside that physical space, it is something that we can trust, usually, including the devices and the users, basically. So physical security was like the key important. So that's no longer like the something that is so critical because there's multiple other pillars that we should consider with the same level of importance as the other pillars, for example, not just the physical infrastructure, for example, but to secure that we should secure the identities, the applications that we are creating, developing, or accessing, the endpoints, the cloud infrastructure, the infrastructure as a service, compute or virtual machines that we're creating, its operating systems, its endpoint protection, the virtual networks that we're creating, and so on. So zero trust teaches us to never trust and always verify. But zero trust is also associated with these other three concepts too. Verify explicitly, that means that we should always authenticate and authorize the identities based on all of the available data points, including the user identity, considering its or reported source location, the device health that that user is using or the status, the service or workload that the user is trying to authenticate to, the classification of the data to protect the data that the users are consuming with the use of those applications and those endpoints after the user is successfully authenticated and authorized. And we're continually checking in for anomalies or risk or potential risk in that part. The other concept is that to use the least privileged access, and this is associated to a decision or a good design that we should consider to only assign the access that the user actually need, no more than that. Because associating more privilege, more permissions that a user that actually requires for his daily operations, we can introduce some other potential risk that we don't want to if that account is compromised by an attacker, for example, and that account already has more privilege than the ones that the user actually need. So an attacker can leverage to perform a privilege escalation or using that account to perform some more damage or to gain access to a different accounts or different resources, basically. So it is important to, with the concept of use least privilege access, that we can use the just-in-time access and just enough access, for example. So we can use different strategies like privilege identity management or privilege access management to establish a mechanism to configure users to become eligible to receive a role. And a role would be a combination of permissions. But if the user is only becoming eligible for a role, that means that the user is not receiving a permanent role. It's just receiving a role that the user can request. And that request process can be associated with multiple layers of authentication and verification for the user. And if the user is able to pass through all of those filters, somebody can accept the request. And then if the request is accepted, the user will elevate his role, but only for a certain period and not with a permanent access. Without this just-in-time or just enough access or just-in-time access, usually the user is receiving a permanent role by a user with a higher privilege than the actual user, by an administrator, for example. And usually those roles associated are permanent ones. So we don't want that if we are working with hundreds or thousands of objects that represents users, to have administrators using his time only to perform that control of the role assignment and unassignment manually, basically. So what we can do is to use these techniques like the privileged identity management and just to define from the beginning and just one time which users will become eligible because they eventually will require to modify his role to perform certain operations, but not the operations that they use on his daily base. Maybe when they need to eventually a couple of times a week to to use other level of permissions to perform um, a few operations or a few tasks, basically, but that they are required to perform those tasks um, on a regular base, basically. So they don't need also to start making requests every day to elevate the role. So we can think into those group of users that can qualify for configure it as eligible for role only. They can have a lower level permanent role for the ones that or the tasks that they need to perform um, every day, basically. But we can think into the other eventual level of permission that usually are going to be with a higher level of permissions to make those levels of permissions to become only eligible and not with a permanent one, for example. And the other concept is to assume the breach, assume that the attackers can and actually will successfully attack anything that they can in a system, including different entities like identity, network, device, applications, infrastructure, and using many techniques available there and plan accordingly also. But we could use the segmentation of access by network, subnetting, user devices, application awareness, and so on. Encryption to all sessions end to end. Use the analytics for the threat detection, posture visibility, and improving defenses also. Now, this is really interesting. There is a lot of concepts here. Let me try to explain a little bit about this. It would be difficult, but well, let me try. We can divide this image or diagram into two separate sections on it. Let's say that we can have at the middle of the image like a line that divides the device risk, the section that divides the potential device risks, and the other that makes another division about the user's risk. And there is multiple. We can see that right at the middle, we have a conditional access. So we can identify that as a pillar for conducting a real zero trust, to never trust, but to always verify. We can see conditional access policies at the middle because this is the type of policies that we can configure at the tenant level into our subscription to continuously monitor the condition of an entity attempt to authenticate and authorize. So a conditional access involves using multiple signals that can be evaluated in a multi-layer approach. And if those multiple levels of verification did not comply with the policies that we can previously set, for example, we can configure the conditional access with an access control that automatically and dynamically will grant or deny the access to as an authentication authorization attempt, basically. So, and these two main entities, the users and the devices, are involved into that process for authentication and verification. So we can see that there is multiple other services involved on it. Of course, we have Azure Active Directory on the middle because this is the directory service that every Microsoft Cloud service will use by default to authenticate and authorize a user. It's a directory service in the cloud as a directory as a service. And it's a software as a service that we can use to authenticate users, basically. And this is where we can just create our new objects representing users, or that we can establish a synchronization to synchronize from an ADDS to Azure AD users, for example. Um, Next to the Azure AD, we can see that also there is the Azure Active Directory, but business to business and business to consumer model. With the business to business, we can invite guest users from external or for partner organizations, for example, and they eventually can authenticate and authorize, and they can have permissions into our tenant. Business to consumer is a special tenant that we can create, especially for clients, where we can register the applications that the clients will consume, and the clients can authenticate with the V2C tenant and apps using not just Azure AD authentication, but we have the possibility to integrate federation with other uh, identity providers like support Facebook, Google, Twitter, LinkedIn authentication, and many others that supports the modern authentication protocols. For example, now at the same time that we are evaluating the user risk, there's multiple other elements involved on it. Like for example, if we would like to enforce the or adding multiple layers to authenticate a user, optionally we can turn on multi-factor authentication. That means that a user no longer need to authenticate only to provide its username and a password, because passwords are like the most easy way to steal a credential for a user or for an attacker to impersonate an account, for example, for stealing credentials using different methods like social engineering, brute force attacks, and so on. So with this, we can add a layer of protection that can prevent that or minimize the risk of an account to be compromised like that. If we are using or we're turning on an MFA, the user, a part of just authenticate with a single layer of defense with a username and a password, the user is prompted to use another method of authentication along with the username and a password, of course. Something that the user can possess, for example, like a mobile device with an application synchronized, like Microsoft Authenticator, and once that the user is configured with that authenticator and synchronized with this account, all the time the user needs to sign in, needs to open the application, tap into the app, or generating a temporary code that the user needs to provide as a second layer and proof of verification. And only when the user passes through that MFA, the user is authorized and is receiving the role and is successfully signing in, basically. If it is not a real user, but is an attacker that already guessed the password, steal the password from the user, finally the attacker will need to have access also to the temporary code generated by a physical or virtual device. For example, that usually the end user will be the only in possession, unless that the attacker is also already, let's say, with control about the device that or the mobile device that the user is using on it. But we're adding another layer of protection on it that is not not too simple anymore, just to steal in a password for a user, and that there is multiple techniques available for that they could be really quick for the attackers on. Along with the MFA, also we can integrate a Hello for Business that involves into a device using Windows, for example. Third-party MFA, we need it also. By using or turning it on or using a license at the Azure AD level, like the Azure AD Premium P2, we can just configure and turn on a couple of policies for identity protection. This policy will help us to identify real-time sign-in risk or user risk when any user is signing in with or without the MFA. And if there is a potential patterns identify automatically with the policies that uses machine learning behind the scenes. If there is a pattern associated with one of the risk or the attacks, it is going to flag for a risk level that goes from the low, medium, and high. And if we have the proper policies configured to react on the lower risk or the medium and above, including the high, those policies can help us to block the sign-in attempt for that. If there is a detection of that an account is compromised, a password is being stolen on it, if the source IP address is trying to be hidden with a VPN or a proxy, if that pattern for that user, it is reporting impossible travel location because the user signed in 2 times from different places that are impossible that in that short period the user could be in the 2 places at the same time, for example. So those kind of risks will be identified automatically. A risk will be generated and classified, and depending on how we just configure the policy can react to a risk detected, and it can optionally block or access if we don't want to accept that level of risk, or it can grant the access, but only with the condition that the user complies with an access control, that the process can be forcing the MFA so the user can configure or need to verify that he claimed that he is the real user by using the multi-factor authentication, or asking the user a password reset for security reasons on it. If he's the real user, the password reset passes through some sort of multiple methods of authentication, similar than an MFA on. So if the user is able to reset his password and sign in again, means that already complete the process. It means that the user verifies his integrity basically with some sort of multi-factor authentication. And at the same time, if we are consuming an M365 subscription on it or Office 365, we can include with our subscription on it the integration of a Microsoft Defender for Identity, Microsoft Defender for Cloud Apps on it to check on continuously if there's a level of risk but represented by a different entity than a user. For example, like for the application that I'm using after successfully authenticate. Now, if a user is able to successfully authenticate, pass through the authentication process, but what happens with the app that the user is authenticating maybe with Azure AD and with MFA? The application can be the one that is compromised, not the identity, basically. So we can use Defender for Cloud Apps also to monitor and detecting shadow IT and so on, and check in and log and react and generate alerts and mitigate risk associated about security postures, but into the applications that we are consuming or that the members of our organization are consuming. The same applications as the Office 365, Dynamics, or third-party clouds also, or modern applications, or third-party software as a service applications that are the ones that provide value for the business, for example, like a Salesforce, Dropbox for storing data, Box, ServiceNow, and so on, third-party clouds and so on. And well, if we take a look at the device risk, here in this case, like I was that is at the beginning of the module, which is a state that with the bring your own device tendency, now it is not a requirement to working fully on a Windows environment or a Windows domain environment with Windows Server and Windows Client operating systems on. Users can use multiple devices at the same time and with different operating systems on it. But it's also important to have visualization, monitoring, and detection and risk detection for these many and multiple types of operating systems that eventually the users will use as endpoints to sign in. So that's another way to protect another layer, basically, because we can detect, remediate, and protect users by authentication and authorization process on it. But once the user is authenticated also, once that we already know that the applications that are secure to access, then what happens with the endpoints, with the devices that the users that already authenticates and that already has access with applications? What if the device is or the endpoint is the one that is compromised on? So it's a good idea to also keep the monitoring of those entity or those endpoints basically, and make sure that they are following some security baseline, that they're up to date, that they are not representing any unnecessary risk basically. And we can use MDM solutions on it, like third-party ones from partners like AirWatch and many others, or thinking on the one that the same home or the same house provides on it, like the Microsoft Intune, for example, for checking in continually device attributes, that we can include mobile device management policies and mobile application management policies to the devices, and checking in with conditional access also as one of the multiple signals that conditional access can evaluate if the device is considered a secure one or considered to be in compliance, under the compliance, for example. If already it is under the enroll and register with the Microsoft Intune, so that means that it is being monitored. And eventually it will be authenticated with encryption, for example, encryption of the entire device if it is owned by the organization, or with the encryption with the mobile application management policies. Classify, detect, and protect only the content that is classified as owned by the organization and not the personal, if it is a personal device, for example. So around that the device and the possible content and documents that that device can download, because the endpoint will have its own storage. So they will have the possibility to copy some content and store it there and so on. So we can apply policies to prevent that some particular content to not be able to be downloaded or sent as attachments into emails, for example. So this is where we can just consider the policies that we can use, and including the rights management service or the information protection, for example, the Microsoft information protection agents, for example, and that we should be able to protect the documents that we're creating there with at least the encryption, classification, and if we already have a proper classification, like taking care about the content that is considered as confidential, to apply different policies or different rules and preventing that content that is sensitive or critical for the organization uh, to be able to be downloaded, copied, printed, or something like that. Okay, so there's multiple concepts associated with this one, but I hope that I can just um, make my best of my efforts to explain. But everything is around the conditional access, but because conditional access has multiple signals to be evaluated, the main two type of signals to evaluate around an entity will be for the user's risk and for the device's risk. That zero trust is divided into different pillars on it. So it's a good idea to have protection or to keep a look on all of these pillars on it. If there is no, let's say, like a value that we are adding, if we are just focusing on only protecting identities, if we have poor endpoints, poor data protected, poor applications or infrastructure or the network on it. So the pillars are divided into security identities, whether they representing people, service, or devices. It's a good idea to define into the zero trust control plane when an identity will attempt to access a resource to verify that identity with the secure authentication or the strong authentication with multiple layers and ensure that the access is compliant and typical for the identity. And that we should follow the least privileged access principle for that. The users should have the permanent roles that only requires to perform his daily operations, or that the users are, if possible, eligible for other higher level roles that the user passes through a process for authorization, for example. The other pillar is to secure the endpoint. So once an identity has been granted access to a resource and they have roles or permissions with or without the elevation of access and so on, the data can flow to a variety of different endpoints on it, from IoT devices to smartphones, or they could be bring your device or to partner managed devices on it, or an on-premise workloads to cloud hosted service. So this diversity creates a massive attack surface area. So it's a good idea to monitor and enforce device health and compliance for secure access also. Then we can take a look at securing the data. Security teams are protecting data, so where possible, the data should remain safe, even if it leaves the device, applications, infrastructure, and networks under the organization controls. And we should have data already classified, labeled, and encrypted, and we should restrict access based on those attributes. Then they're secure for applications also. Applications and APIs will provide an interface by which the data will be consumed by the users at the end using its endpoint, its secure endpoints on. So they may be legacy on on-premise applications on it, lifted and shipped to cloud workloads or modern software as a service apps. It's a good idea to apply controls and technologies to discover the shadow IT. The shadow IT concept relies into identify all of the applications that the organization are consuming through its users, basically. So we should make sure that we have appropriate application permissions, that we should gate access based on real-time analytics to monitor for abnormal behavior, control the user actions, and validate secure configuration options also. And it's a good idea to secure the infrastructure, whether the on-premise servers, cloud-based virtual machines, containers, or microservices. This will represent a critical threat vector. So we should assess for version, configuration, the just-in-time access to harden defense. A good idea to use telemetry to detect attacks and different anomalies and to automatically block and flag the risky behavior and take protective actions on it. And finally, we should protect another pillar that is the secure the network on it. So all the data will be accessed over some network infrastructure. So networking controls can provide also critical controls to enhance the visibility and to help prevent attackers from moving laterally across the network on it. So a good idea to have network segmentation, microsegmentation with subnetting, and a good design. And we should deploy real-time threat protection with end-to-end encryption with the communication, the monitoring, and the analytics. Those are associated with the pillars on it. And next section or topic is to build an overall security strategy and an architecture. So organization need security models that can adapt to the complexity of modern environments on protecting devices, applications, data, wherever they are located, people, users, content and data, and so on. So the term security strategy reduces the business risk from attacks and will ensure that we have confidentiality, integrity, and availability assurance built into all information systems and the data. So as the operational technology and Internet of Things devices are introduced, so security often is also focusing on assurances of safety from devices controlling physical processes. And the architecture is defined as a specific design to address the information systems and to fulfill an information security requirement. So we are going to take a look at another concept that is the Cybersecurity Reference Architecture, or the MCRA, for the Microsoft Cybersecurity Reference Architecture. And what is this? It's a series of best practices or the standards that we can follow to just helping us to make designs on different architectures to protect the multiple entities that will include the data, the users, the networks, and so on. And there is a repository for that. So develop security requirements based on the business goals. We can take a look at the MCRA, or the Microsoft Cybersecurity Reference Architecture. Give me a second here because I already have the page with a URL here with the MCRA. This is the official page, straight from learn.microsoft.com to the Cybersecurity Reference Architecture / MCRA. Describes the Microsoft cybersecurity capabilities, and we have a series of diagrams that describe how the security capabilities can integrate with Microsoft platforms and with third-party platforms like other clouds and Microsoft 365, Microsoft Azure, third-party apps, and so on. So we can download the file from here, this file that includes all this. If we would like to protect the people or the users, if we need zero trust user access, we can access to this diagram, for example, or this reference architecture, the one that I already described a couple of minutes ago. There is others for security operations, others for operational technologies, other for secure access service edge, for multi-cloud and cross-platform, for attack chain coverage, for Azure native controls, and for other capabilities, for example. So, and you can access to this by going to the aka.ms/MCRA for the Microsoft Cybersecurity Reference Architecture, you will be redirected to this, basically. And if you click here to download the file, then you actually will download the information into a PowerPoint to take a look at all these designs and all the details, because the images are like a thumbnails here, and there's a lot of concepts around multiple edges, multiple relationships. So by looking at the PPTX, the PowerPoint presentation slides, that there's multiple slides, then you can see it into a high resolution, and you can zoom in and out and take a look at all of these ones. So these architectures are composed of detailed technical diagrams of Microsoft cybersecurity capabilities, zero trust user access, security operations, operational technology, multi-cloud, attack chain coverage, native security controls, and security organization functions. So the cybersecurity reference will describe the Microsoft cybersecurity capabilities, and a series of diagrams will help us to describe how the Microsoft security capabilities will integrate with the Microsoft platforms and also with third-party platforms like Microsoft 365, Microsoft Azure, third-party apps like ServiceNow, Salesforce, and so on, and third-party clouds like AWS, GCP, and so on. The reference architecture are composed of detailed technical diagrams on the Microsoft cybersecurity capabilities. So, security requirements based on a business goals. During any cloud transformation or digital transformation, for example, the ability to speak in terms of business outcomes supports transparency and some cross-functional partnership. So a good cybersecurity architect should be also a person that can communicate with different stakeholders on it. The business outcome framework will start with a simple template that can help to technically help individuals with documents and to gain consensus. And this template can be used with the business stakeholders to collect different business outcomes, which could each be influenced by a company transformation journey. And the business outcome template will focus on simplified conversations that can quickly engage the stakeholders without getting into deeply into technical solutions. So by quickly understanding and aligning the key performance indicators or the KPIs and the business drivers that are important to the stakeholders, the architects can consider about high-level approaches and also transformations before implementing some security solutions. Another concept that is the Cloud Adoption Framework, or in some documentation you can find it as the CAF, Cloud Adoption Framework. This, to govern the stage, focuses on the cloud governance. We can make a reference to the Cloud Adoption Framework for recommended guidance as we are building our cloud governance strategy. And the word governance is associated to control whatever we have running on, basically on it. For example, when we talk about governance, we can think technically into how can we apply policies for governance. And with policies, or with Azure policies, for example, if we wanted to see it into the Azure platform, to govern our subscription and resources, I can use the Azure policies and initiatives to specify with the policies that something that whatever that I want to have into the different type of resources or environments, I can translate that into a series of policies, or whatever that I don't want, especially into my environment, like resources to be created or resources to be created into certain regions for compliance, legal, and governance needs. For example, we can set and pre-configure all those series of policies that aligns with the organization requirements to make sure that it doesn't matter who, when, and how try to create or modify something, and independently if the user has the permissions to do that, because a policy will be all the time on top of the permissions. It doesn't matter and at which time, if the user tries to do or perform an operation that is not accepted or that is not allowed by my series of policies that I have, then the final action for that will be you are not able, you're a deny basically. So that's about what we are talking about, the governance on it, to get the control of something and that we don't need to have some user or that we don't need to perform that governance manually basically. So to help to build our adoption strategy, the cloud adoption framework is breaking out multiple stages into further exercises and steps. And we can go for the aka.ms/CAF secure to be redirected to the cloud adoption framework official page. What can we do with the CAF? Give me a second also to check it out. The CAF is here. Yeah. What is the Microsoft Cloud Adoption Framework? For Azure in this case. So the Cloud Adoption Framework can help us to get started with several different getting started guides. The secure methodology will provide a vision of the complete end state to guide the improvement of our security program over time on. And we can see that there is multiple stages that we can start with a adoption journey. And we can take a look at an overview. Get started with the cloud adoption framework, and we can see here some cloud adoption scenarios, accelerate, improve the controls, establish the teams, and so on. Then we can move on to a strategy. And well, to develop a cloud adoption strategy, then, okay, improve business agility, reduces the cost, accelerate time to market, enable expansion into new markets, and so on. And then we can move on to a plan, a readiness, adoption, governance, management, secure, and organize. Well, this part of resources are for tools and templates that we can use, but the last one we can identify as the organizing or managing the organizational alignment, for example. The structure type that we should consider, virtual teams, organization chart alignment, managing a hierarchy, responsibilities, and so on. And well, some of these stages that we're going to see here to define the strategy. Here, we can answer to questions like why the organization is moving to the cloud and when we want to get out of cloud migration. So do we need to scale to meet demand or reach new markets? Will it reduce costs or increase the business agility? And when defining the cloud business strategy, we should understand the cloud economics also. Consider the business impact, turnaround time, the global reach, performance, and there are different steps to define the cloud strategy, like defining and document motivations, document business outcomes, evaluate financial considerations, and understanding technical considerations also. The other section for governance and management of the cloud environments, cloud governance is an iterative process for organizations with existing policies that govern on the premise IT environments. Cloud governance should complement those policies, and the level of corporate policies integration between on-premise and the cloud will be different depending on the cloud governance maturity and the nature of the digital state in the cloud. So as the cloud state changes over time, so do the cloud governance processes and the policies. So some of the steps into the governance process of this stage to use the different stages, like establishing a methodology to establish a basic understanding of the methodology that will drive the cloud governance in the cloud adoption framework to begin thinking through the end state solution. Number two, to use the governance for benchmark tool to assess our current state and the future state to establish a a vision for applying the framework. Number three, to establish an initial governance foundation that we can begin our governance journey with a small and easily implemented set of governance tools. And this initial governance foundation is called an MVP, or minimum viable product. And number four, to improve our initial governance foundation throughout this implementation of the cloud adoption plan. We can iteratively add governance controls to address tangible risk as we progress towards the end state. For the stage of management using the cloud adoption framework, there is other different concepts, like we can define business commitments. Here we should document supported workloads to establish some operational commitment with the business and agree on cloud management investment for each workload. That we should establish a management baseline. Here we can define the critical classifications, the cloud management tools, processes required to deliver minimum commitment to operations management, and to expand the management baseline based on the business commitments and operations decisions to make use of the included best practices to implement the required cloud management tooling and the advanced operations and design for platforms or workloads that will require a higher level of business commitment, might require a deeper architecture review to deliver on resiliency and reliable commitments also. And well, a breakout section here to design technical and governance strategies for traffic filtering and segmentation. Now, this is something that it goes a little bit more technical than the focus of the course, but well, it is a good opportunity to start explaining something of this ones or these concepts. Some best practices for network security are associated to logically segment subnets. We understand that we can create virtual networks, but to design a secure architecture, for example, it is good to understand, and also this involves, because usually a virtual network is like the foundations of an overall solution, especially the ones that involves the compute or the infrastructure as a service compute for virtual machines, for example, because eventually we will need to create a virtual machine. And even for the resources that are into the platform as a service model, like the Azure SQL databases, the storage accounts, and so on, we don't see a virtual network that we are responsible for that we can manage. However, that doesn't mean that there is not actual networking for those services on. There is actually networking there, and there is something that we can do and configure for that, like configuring public service endpoint, private link, and so on, allow the public access or not, for example. So we have different layers that we can apply at the network, even when we're working with platform as a service. But well, in this case, when we can logically segment subnets, that means that we are working with the infrastructure as a service model. So that means that we have the responsibility to design and create the virtual networks that we need to use, basically. So a good recommendation is to logically segment with subnetting, for example. So we can establish a design for a multi-tier architecture, for example, that we can have a front-end tier, a business tier, a data tier, for example. And using that logical segmentation, we can have better security because we understand that if we have different subnets, we can apply different security rules or different security needs by using separate security groups on. Of course, that the front end or the web tier will have different needs than the data tier, for example. So we cannot apply the same security rules on it. So if we would like to protect those tiers on it, we should apply the security that every subnet will require, instead of working with a single set of security rules, for example, to the entire virtual network, because we don't need the same security rule for all those tiers on. So performing that logical separation, we can have better administration of the networking resources, the IP addressing, we have an order for that, and we have better security on it because only the traffic that we want explicitly, that's the one that we will accept, and we don't need to have some other security holes or bridges on it that accepts more traffic than the one that we need. We should adopt the zero trust also, including into the networking concept. Because today employees can access resources from anywhere, and we should secure administrators, and that they need also to factor in how a resource is being accessed. In the perimeter-based networks, we should assume that all systems within a network can be trusted on. And the zero trust concept with the architectures will use the device and user trust claims to gate access to organizational data and to resources. We should control the routing behavior also, because there are times when we want to customize the routing configuration. Usually in Azure Virtual Networks and with networking, we will deal with system routes that automatically will be configured and that will support, that will be dynamically configured and adapt to our networking designs on it. So when we are, for example, establishing peering between different and isolated networks, which is the default, there is no need to specify or to update our routing table on. Just need to establish the peering, and the system router is taking care about allow the traffic between networks, for example, unless that we specify something different with a explicit deny, for example. But sometimes we need to have a different behavior than the one that the system route provides. The system route will try to all the time get from point A to V with using the path that is the cheapest path. And I'm not talking about the cheapest or the most expensive in terms of money, but the cheapest or the most expensive into the way of the number of hops that one traffic goes from point A to V, basically. The system route tried to be the most efficient as possible and try to make the less number of hops to get from the point A to the V. In some cases, the cheapest path, it is not the most secure, basically. So sometimes we need to make more hops, but in order to follow a security strategy, like in the case when we are just establishing a security appliance or a network virtual appliance, for example, and that we are using that network virtual appliance for checking in and for continuously monitoring the traffic, for example. So that's an example of where we can use a custom route table to send some traffic from one place, but instead of going for the shortest path from point A to V, first go to a point C instead of going straight to B, but goes to the point C where their security appliances is for checking in some traffic or for logins for monitoring and analytics, for example, and finally get to if nothing suspicious is detected, finally get to the destination point that could be the V, for example. We can use some virtual appliances because, well, like my previous example, with a virtual network appliance, we can have the level of control or security that maybe we are familiar to, because these virtual appliances will be associated with other vendors or third-party providers, for example, that maybe it is the one that we are using for our physical infrastructure or the physical network infrastructure into our on-premise, and that we want to extend to the cloud, for example, we can consider using a virtual appliance for that. Network security groups and user-defined routing can provide a certain measure of network security as at the network and transport layers, taking the reference of an OSI model. But in some situations, some security needs to be enabled at high level of the stack. So in such situation, it is recommended to deploy virtual network security appliances that usually are provided by Azure partners and that we can find into the Azure marketplace, for example. And Azure Network Security appliances can deliver better security than what network level controls provide sometimes. We should deploy perimeter network for security zones. A perimeter network, also known as a DMZ for demilitarized zone, is a physical or logical network segment that would provide additional layers of security between assets and the internet. And there could be specialized network access control devices on the edge of a perimeter network that allows only desired traffic into a virtual network. So based on the zero trust concept, we should consider using a perimeter network for all high security deployments in order to enhance the level of network security and access control for Azure resources also. We should avoid exposure with dedicated WAN links also because, well, organizations have chosen sometimes the hybrid IT route. With hybrid IT, some of the company information assets are stay in the Azure cloud and others remain on the on-premise. So in many cases, some components of a service are running in Azure while other components remain on the on-premise. In a hybrid IT scenario, there's usually some type of cross-premise connectivity. So cross-premise connectivity allows the company to connect its on-premise network to Azure Virtual Networks. It is recommended to also use load balancing solutions to optimize the uptime and performance. A load balance will help us to have a service with high availability or reliable against single point of failure, for example, because the job of a load balancer is to continuously monitor multiple services into its backend pool. And those services can be different compute services or different virtual machines that are independent from the others, for example, across different availability zones, sometimes using the same region, but across different availability zones. So we're avoiding a single point of failure. If one of the instances fail to provide a service, maybe I have another virtual machine providing the same service, however, into a separate availability zone within the same region. That availability zones by design are isolated from the others. So load balancer can detect and know all the time what are its backend pool instances and can continuously monitor and send help props. When one help prop is not responding back from the service after certain conditions, like for example, 2 props in a range of 5 seconds each, in other words, in 10 seconds with no response back from the service, that means that that service is into a failure on. And the load balance can detect automatically that, and it can automatically send the traffic to the last instance reporting to be helped from its list, basically, because there could be 2 or there could be more than 2, for example. But the helpers are still being sent on the same frequency every 5 seconds to all of the instances on its backend pool, because the instance was not permanently deleted. Maybe the services experienced a failure into the service that we are load balancing, like the HTTP or the HTTPS port not responding back. But eventually, if the resource recovers, it will start to now responding back, and the helpers will still try to receive a response back on it. So in every 5 seconds, it's sending 1 to all of the instances on. So eventually, when that instance recovers, it will start to reporting to be held again, be available, and now returns to a different status into its held prop list, into its backend pool, as a healthy instance on it that can receive a traffic and provide a response back to the end user on it. So it will help us to achieve a highly available service on it that can still be available even in the case that there is a failure reported by one of the other instances available, for example, under the load balancing solution. And finally, is a good idea to also secure critical Azure services resources to only our virtual networks. And usually we can do this by using services like private links and public service endpoint. The Azure private link and the public service endpoint. That means that there are different models for services, especially into an Azure subscription. Mostly we can identify two of them: infrastructure and platform as a service. With the infrastructure as a service, those are when we are responsible for the operating system and all of the other layers above. So, like working with Azure virtual machines or virtual machine skill sets, for example. And the other are the platform as a service, when we are no longer responsible for an operating system, servers, and so on. So mostly when we would like to protect an Azure service to only virtual networks and use it with private links or private servers endpoint is when we are talking about PaaS services. So some PaaS services like Azure SQL databases, storage accounts, Cosmos DB for the NoSQL databases, and so on, service bus queues, Azure Active Directory, um, well, many other PaaS services. We can configure so for a specific virtual network. Let's imagine that this is my VNet, and one of my subnets is another rectangle inside one of my VNets. We can specify a secure connection from this source, and the destination could be, for example, my relational database, my RDB, that is operating into the platform as a service. There is no VNet, there is no subnet that I have here, but I have some network access control or network access or something like that. So I can turn on at the VNet and subnet level a secure link between this virtual network and subnet and all the resources inside this subnet. Let's say that in this subnet I have a virtual machine called VM1. So what if my VM1 needs to communicate but securely through this relational database? So instead of this VM to go and to have a, let's say, the public access accepted at the database that is not recommended, my VM that is into this subnet can use the secure logical link to communicate with the database without overexposing my database for public access, for example. So we can configure that public service endpoint that at the end is resolving a public IP address, or using the private link, that the private link creates a kind of a virtual private network adapter. And with that private network adapter, I can access to the database, but with private IP address, basically. And it's not going to the internet or not resolving a public IP address. So I will achieve better security, let's say, or better, more secure access across different services within the same or different models, from infrastructure to platform, or platform as a service to another platform as a service, for example. Okay, we have, let's say, the end of this first part of the module 1 for the presentation, and we have a case study. So the case study is the next one. The case studies are associated with a fictitious case. And this fictitious case is like, okay, imagine that you are working with a fictitious organization that it doesn't exist, but it's just for the educational purposes. And well, Microsoft already stopped to use Contoso and so on, but switches recently to Tailwind Trader, is planning on making some significant changes to their Azure architectures. And they have asked for your assistance, that we are the Azure security or the cybersecurity architect, with recommendations and questions. And here are some specific requirements. They need user access and productivity. So for that, the company has a new security optimization project for customer environments. And the CISO wants to ensure that all Azure resources are highly secure. And for the architecture review phase or stage, user accounts should require, for example, a passwordless mechanism or an MFA for all users, and be able to measure risk with threat intelligence and behavior analytics. Another requirement is that the endpoint should require device integrity for access. And number three is that the network should be able to establish basic traffic filtering and segmentation to isolate some business critical or highly vulnerable resources. So the task or the questions for this case are: what are the different ways that tailwind traders could use the Microsoft or the MCRA to require passwordless, or to MFA or multi-factor authentication for all users and be able to measure risk with threat intelligence and behavior analytics. Now, if you would like to answer the questions, you can use the Q&A section on it. Publish your answer in the form of a question, no problems on it. But well, the moderator will take that as okay. You already provide your answer. And then number two are: what are the different ways that tailwind traders could require integrity to access endpoints using the MCRA? And there's a question number three. The Microsoft Cybersecurity Reference Architectures. The number three, what are the different ways that tailwind traders could establish basic network traffic filtering and segmentation to isolate business critical or highly vulnerable resources using the Microsoft Cybersecurity Reference Architecture, or the MCRA? Okay, provide your answers using the Q&A. Sorry. And I will give you a minute for you to provide those. And then next I will present the case study solution and some of the recommended answers to this case, basically. All right. Solution for the questions are: so what are the different ways that the tailwind traders could use the MCRA to require passwordless or MFA for all users and be able to measure risk with threat intelligence and behavior analytics? So by considering using all these elements on Windows Hello, which is an option that you can find it available for Windows devices or Windows 10 devices, that uses a trusted platform module chip, physical chip built into the devices on it, that we can just turn on with Windows 10 or Windows 11 and use that for encrypting the way that we are accessing and that we are authenticated against the device, like with using a password or password replace it with a PIN or with a fingerprint authentication, for example. Using FIDO for fast identity online, usually it's a key, and usually it's into a USB format, a USB key that we can use to authenticate, that is considered a passwordless option. We're replacing password by using a USB key, for example, or using another passwordless option that is using an authenticator app, for example, which is one that I'm using usually for testing into my mobile device on it for different sessions and deliveries. We should consider using Defender for Cloud and M365 Defender for the measure the risk with threat intelligence, and behavior analytics, and using Sentinel for the threat intelligence and analytics as a SIEM, security information and event management. For the second question, what are the different ways that tailwind traders could require integrity to access endpoints using the MCRA? To use conditional access policies to evaluate the different signals, some of the signals to the users, some others for the devices or endpoint state or status, and Defender for Cloud app for checking in into the shadow IT and the security posture of the applications that the users are consuming. And for the number 3, what are the different ways that tailwind traders could establish basic network traffic filtering and segmentation to isolate business critical or highly vulnerable resources using the MCRA, to use subnetting, the virtual network traffic filtering, or NSG and application security groups as a complementary, and optionally as the Azure Firewall and Firewall Manager. We have another cybersecurity reference architecture that these are more interesting, but if time allows, we're going to evaluate more deeply on, for example, okay? But also you can find it into the cybersecurity reference architecture as one of the images that you can have for downloading. The interesting sections are the security operations on it that involves the SIEM, the Microsoft SIEM, the Sentinel, Defender. So depending if we are working with Azure subscriptions or with the Microsoft 365 subscriptions on, that the Defender is a family of products that includes Defender for Cloud, for Endpoint, for Office 365, for Identity, for Cloud applications, and integrated with Defender for Cloud for IoT, for SQL databases, and so on. And we can find out the section for the endpoints and devices protection with that MAM, Microsoft Endpoint Manager, Defender for Endpoint, and so on. Defender for Cloud Suite, that is not just limited for the Azure subscriptions, but also along with the Azure subscriptions, we can integrate third-party clouds, for example, like AWS and GCP connectors. There is a section for information protection here. Well, this is for hybrid infrastructure as a service, platform, and on-premise, that we can include servers, for example. Conditional access, Azure Active Directory, and the protection across the Azure AD, passwordless and MFA, Windows Hello, FIDO2 keys, identity protection, privileged identity management, identity and governance, business to business, business to consumer, and so on. And there is other sections here that we can see it as the IoT and operational technology, privileged access workstation, Microsoft Compliance Score, people security, GitHub, security development lifecycle, and so on. Different layers of protection. So we have a module summary for the number 1. In this module, you have learned partially, because you will have for homework some other topics. Learn about how to build an overall security strategy and architecture with zero trust in mind. And you have learned different strategies for designing, defining, and recommending an organizational security strategy and architecture. And you should now be able to develop integration points in architecture, develop security requirements based on business goals, translate security requirements into technical capabilities, design security for a resiliency strategy, design a security strategy for hybrid and multi-tenant environments, design technical and governance strategy for traffic filtering and segmentation, and understanding some security for protocols. All right, guys. I'm switching over to module 2 because we have approximately another 24 minutes. Give me a second to start loading the module 2. And again, for today, we have another 3 topics to cover from module 2. The lessons are the understand security operations framework, processes, and procedures, design a logging and auditing security strategy, and develop security operations for hybrid and multi-cloud environments. From module 2, and the topics that you will take as your homework will be another 3. Design a strategy for security information and event management, and security orchestration, evaluate security workflows, and review security strategies for incident management, right? That's the plan. Okay. Let me start presenting module number 2. Design a zero trust strategy and an architecture, and design a security operations strategy. This section starts with the understanding security operations framework processes, and procedures. And we can see that there is a multi-layer, there is a cycle. It starts, for example, with detection, going for different other levels like investigation, remediation, hunting, threat analysis, vulnerability, threat experts, protection, and against returns on. So with each of these individual areas, generating these relevant alerts and integrated capability will be needed to manage the resulting influx of data to better defend against threats and to validate trust in a transaction. So abilities needed on it is to detect threats and vulnerabilities, to investigate, to respond, to go hunting, to provide additional context through the threat analytics, to assess vulnerabilities, to get help from world-class experts, and to prevent or block events from happening across the pillars on it. The process to managing threats will include two, let's say, modes: reaction and reactive detection and proactive detection. For reactive detection, here the incidents are triggered from one of the 6 zero trust pillars. And additionally, a management product like security information and event management will likely support another layer of analytics that will enrich and correlate the data. At the end, resulting in a flagging and an incident as bad. And the next step will then be to investigate to get the full narrative of the attacks. While the proactive reaction is when we decide to go hunting with the available data to prove an hypothesis of the compromise. And then threat hunting will start with the assumption that there has been a breach. And the goal is to hunt for proof which will confirm the assumption. And that's why it's called a hypothesis, because it's only an hypothesis until we can prove that there is that we can confirm that there is an attack on it. So that is more like a proactive detection on it, that we don't have the proof, but that we have some that we are suspicious about that, and that we are just going to do whatever is possible into the hunting tools to try to get to the proof, or to prove the hypothesis in this case. The security operation model or the team is often focused on 3 key outcomes. The incident management that involves the reactively responding to detect attacks, proactively going hunting for attacks that slip through the traditional threat detections, and with coordinating the communications, the legal and other business implications of security incidents. But also there is a process for an incident preparation that will help the organization to prepare for future attacks. Incident preparation will be a broader strategic set of activities that are aimed at building muscle memory and context of all levels of the organization. And this strategy will prepare the people to better handle major attacks and gain insights on security process improvements on. And there is a threat intelligence, where there is a collection, processing, and disseminating the threat intelligence to security operations, security teams, security leadership, and business leadership stakeholders through security leadership on. So to deliver against these outcomes, security operations teams should be structured to focus on the key outcomes in larger security operations teams, and the outcomes are often broken out between sub-teams on it. And those teams will be like the automation is when there is automated investigation or remediation. It is not associated with a team of people. But the ones that are associated with a sub-team is the triage or the tier 1. This is the first line of response for security incidents. So triage is focused on the high-level processing of alerts and typically generated by automation and the tools. And the triage will solve most of the common incident types and resolve them within the team. More complex incidents or incidents that haven't been seen and resolved before should be escalated to tier number 2. And the tier 2 is the investigation. The investigation is focused on incidents that require more investigation, often requiring correlation of data points from multiple sources on. And this investigation tier looks to provide some repeatable solutions to issues escalated to them. It then enables tier 1 to resolve later recurrences of that issue type, and tier 2 will also respond to alerts against business critical systems. And then there is the tier 3 or the hunt tier that is focused primarily on proactive hunting for highly sophisticated attack processes and to developing the guidance to the wider teams for maturing security controls. And as a result, the tier 3 team also will act as an escalation point for major incidents into support forensic analysis and response also. The security operations team will have multiple potential interactions with business leadership that will include the business context to security operations on that. Here, the security operations team must understand what is most important to the organization, what will have the most negative impact on the business, downtime of critical systems, a loss of reputation and customer trust, disclosure of sensitive data, tampering with critical data or systems, and so on. Major incidents updates from the security operation should provide updates to business stakeholders for major incidents as they happen, and this information allows the business leaders to understand their risk and to take both proactive and reactive steps to manage that risk. And the business intelligence from the SOC, sometimes security operation, will find that adversaries are targeting a system or data set that isn't expected. So as these discoveries are made, the threat intelligence team should share these signals with business leaders as they might trigger insights for the business leaders on. So for example, someone outside the company is aware of a secret project or unexpected attacker is targeting highlight the value of an otherwise overlooked data set. Some general best practices for conducting security operations is, for example, following some standard like the National Institute for Standard and Technologies or the NIST cybersecurity framework that functions as part of the operations to detect the presence of the adversaries in the system, to respond by quickly investigating whether it's an actual attack or a false alarm, and to recover and restore the confidentiality, the integrity, and availability of the workload during and after an attack. Usually we can use metrics that can help us to translate culture into clear, measurable goals that will drive outcomes. So main metrics to focus on that have a direct influence on organizational risk. And we can identify two main types of metrics on it. The MTTA, or the mean time to acknowledge, that this is referring to the responsiveness measure the time between an alert and when an analyst sees that alert and begins the investigation. Improving this responsiveness will require that analysts don't waste time investigating false positive, for example. And there is the MTTR, or mean time to remediate. With this, we can measure the effectiveness. Is the time that the analyst begins the investigation to when the incident is remediated, and the mean time to remediate identifies how long it takes the security operations teams to remove the attacker's access from the environment. And this information will help to identify where to invest in processes and tools to help the analyst to reduce the risk. Other options to measure is the incidents remediated, either manually or with automation. So measuring how many incidents are remediated manually and how many are resolved with automation is another key way to inform staffing and tools decisions on. And there is also escalations between each tier to track how many incidents escalated between the tiers. And it helps us to ensure the accurate tracking of the workloads to inform the staffing and other decisions. For designing and logging and auditing security strategy on, Now, depending on which security tool we are using, usually depending on the type of subscription that we're using, for example, because a SIEM solution like Microsoft Sentinel or a third party is when we are operating on a hybrid environment or with an Azure subscription, for example. And when we are working with Microsoft Defender or Defender for Cloud, for example, is where, again, when we are working in a hybrid environment or when we have an Azure subscription and a Defender plan, Defender for Cloud plan, for example. So within the same account or subscription, we can have a SIEM solution, security information and event management, but this tool is built into a main repository that is a log analytic workspace. This log analytic workspace is the main repository where the logs through the data connectors are established. So for example, what can we connect to a SIEM through a log analytic workspace? We can connect servers and virtual machines from an on-premise or third-party cloud, network devices, and other type of services on, for example. If we are operating into the Azure environment, like the Azure foundational elements, like the network, storage resources, consoles, and so on, virtual machine with infrastructure as a services, and Azure services with the platform as a service model, like Azure SQL databases, Azure security, or no, ASC is for, I don't remember this acronym. Application security. I don't remember this one. But there is other examples of past services like a NoSQL database and a storage account, a service bus queue, and so on. And well, especially for databases, we can use the Defender for Cloud plan extension to turn on some SQL threat detection on. And these behind the scenes are just activating another initiative with a series of policies aimed to protect and detect and monitor and react eventually to threats associated to relational databases like SQL injection attacks and so on, for example. MDC stands for the Microsoft Defender for Cloud. MDC integration for high quality alerts, log ingestion. Well, Azure Monitor is a built-in service that is monitoring by default by catching the logs and the metrics for the services inside. That's why we are not looking at the Azure Monitor at the on-prem and third-party cloud, because the Azure Monitor is a built-in service into the Azure platform. So we can only see it with the Azure foundational elements, with infrastructure and platform as a service also, with the monitoring service. But eventually everything is ingested into the log workspace, and on top we have the SIEM solution and the Microsoft Defender for Cloud connected to a log workspace on it, where all these logs are stored there. But the SIEM or the Microsoft Defender for Cloud, the Sentinel, or the Defender for Cloud, are services that we can access from the user interface from the Azure portal, for example. But at the end, everything will be stored. But we are using the built-in tools that the SIEM includes, like the KQL queries, built-in, or we can create our own, or we can create alerts. Or the Defender for Cloud that is built in with the recommendations, the series of policies that the Defender for Cloud is using from initiatives like the Security Foundation benchmark, for example, to compare the actual configuration with the desired, following the best practices from the security benchmark, and the lack of compliance for those resources triggers recommendations on. Resources not in compliance are not receiving points. And at the end, we can see a security score from here, from Defender for Cloud. So the security score give us an idea of how secure our environment is comparing to the what's supposed to be if I'm following one or multiple standards for security, for example. So logging the data can provide insights about our application and can help us to troubleshoot past problems or prevent potential ones in the future, can help us to improve application performance or maintainability, and can help us to automate actions that will otherwise require manual intervention. Defending across attack chains on it. And we can see another architecture or diagram with the Microsoft Sentinel here in this little curve, the SIM, Security Information and Event Management from Microsoft. And we can see a section down the line with the insider risks, and another section, the upper section, with the external threat, when we can see that there is a higher range or scope from the external threats for obvious reasons on it, because an insider risk is the possibility to detect people inside the same organization, an insider that is actually acting with or involuntarily or voluntarily to create some risk. For example, like data leakage, potential sabotage, and so on, for example. And there are mechanisms that we can use to use the insider risk management, for example, for detecting some potential vulnerabilities in this, to try to block those, for example. And for external threats, we have different sections. Like for external threats, we have everything that happens about the Office 365 environment. And we can use for protection Defender for Office 365. That we can use a series of mail flow rules to detect some phishing emails, open attachment links, click to an URL like phishing, browse to a website, for example, that are one of the most frequent attacks that members of our organization will eventually receive by email. Attacks associated to endpoints, so we can use Defender for Endpoint for that, to avoid exploitation and installation of unsecure software